Yeah, good evening. Sir, in the last video, just we started recursion concept, right? So what is mean by recursion? Okay. So what is mean by first of all a function? How you can able to write the functions for any task? Sir, once if you are creating a function, so what advantage we are going to get? And next and after that, so is it possible to create a function within another function? And what is the difference between method and function also? We discussed it very clearly in the last video. From that, slowly I defined, sir, what is the meaning of recursion? So how many types of recursions are there? There are two types, right? One is nothing but infinite recursion. Second one is nothing but finite recursion. So infinite recursion means what? There is no base point. It's keep on continuously executing. So in infinite recursion, there may be a chance of getting stack overflow error. Okay. And what is mean by finite recursion? If an instruction is executing up to certain limit, then it is called as a finite recursion. So how to prepare infinite recursion programs? How to prepare finite recursion programs we have seen very clearly in the last videos. And for finite recursion, the important tool is nothing but base condition. So based on this base condition only, we can able to make that particular recursion to be stopped. Okay, so it is a special condition we have to write in recursion. So at certain point it is going to be stopped. Okay, at a certain point it is going to be stopped. So how to use that we have seen very clearly in the last videos. Now, why we need recursion, what benefits are there, and even mathematical interpretation of the recursion, how to prepare formulas for this we have seen. These are the things which we discussed in the last video. Sir, in today's session, I'm going to talk a few more theory concepts. Then I will go with the programs related to the recursions. The first one is nothing but, sir, properties of recursion. Sir, if I want any recursive application, if I want to prepare any recursive application, what properties we have to follow? Sir, first point, when we have to choose recursion means, suppose if you want to perform same operations, okay, if you want to perform same operations repeatedly with, okay, if you want to perform same operations repeatedly with multiple inputs, then we have to go for this recursion. For example, sir, consider in the previous program somewhere we have defined a method called m, or assume, so we have some function is there called f, okay, which is receiving some n value. Sir, later, sir, this function is going to be invoked with n minus 1 or not? Yes, that means what? Same function we are calling. Okay, so continuously this process is called as recursion. Just wait for 1 minute, sir. Yeah, right. Thank you for giving time. Sir, what is the properties of recursion here? Sir, here you can able to see if you are taking function, okay. So next time, how we are going to call this function? F of n minus 1. Next time, f of n minus 2. Next time, f of n minus 3. Like this until it reaches base condition, it's keep on repeating. This is nothing but what we have. Sir, we are performing same activity or not? Yes, but with different inputs. Like if the first time input is 5, next time your input will become 4. Next time your input will become 3. Next time your input will become 2. Next time your input will become 1. Maybe you will stop at 1 or you may stop at 0. This is called as base condition, right? So we are going to perform the same activity but with multiple inputs. If really such a type of requirement is there for your problem, you can able to choose this recursive method. Sir, here we are going to use same operations with multiple different inputs. Same operations with multiple inputs. Okay, for the same problem statement, we are going to invoke same operation, but multiple inputs will be there. This is the first property in the recursion. Okay, whenever you are implementing the recursion, make sure that for the first step, what operation we are doing. So for the second step also, same operation should be there. For third operation also, so for third step also, same operation should be there. Like if any requirement is there, then you have to choose this recursion. Second point, in the case of recursion, we will divide, okay, we will divide the entire program, we will divide the entire problem into small problems. So on the beginning itself we covered, right? Suppose if I have a big problem is there, we can able to solve that big problem, but may not possible directly at a step. That's why what we are going to do, we will divide this problem into small problems so that we can solve these individual problems. But once if you got a solution for these individual problems, by combining all the solutions, you are going to get the solution for main problem. That is nothing but what we have. Sir, what is the third property? Sir, very important. Sir, base condition. Base condition is very important. Base condition is very important in recursion. Sir, else what happens? Else it leads to infinite execution. Okay, let's leads to infinite execution. That means if you are not writing the proper base condition in the sense, if you are not applying your logic properly, or if you write any wrong base condition, then the complete story is going to be ended, because it leads to infinite execution. Already we have seen. Yes, some people are telling stack overflow error, correct. So these are the main three properties of recursion. Whenever you are implementing recursive algorithms, you need to concentrate on these three, sir. What is the first one? Same operation we have to use with different inputs. Second operation, sir, we have to divide a big problem, okay, into small units. So the solution of these small units, if you combined, you are going to get big problem. Then third one, sir, base condition is very important. Okay, base condition is very important. Suppose if you are not writing base condition, what will happen? It leads to infinite execution. These are the three important points that you have to remember while preparing the recursive algorithms. Sir, I can say these are the three important main properties that we have to follow. Sir, please confirm, is these 3 points are clear for you people? Right, sir. Sir, when compared with normal functions or normal problem solving skills, sir, what is the advantages? Okay, what is the advantages of recursion? So what is the advantages of recursion? Sir, it is very important, right? When you are learning recursive concepts, So when compared with other, okay, when compared with other concepts, what advantage we are going to get? Sir, the first one is nothing but, sir, recursive algorithms. So recursive algorithms are easier. Recursive algorithms are easier to write. Recursive algorithms are very easy to write. This is nothing but the first property what we have. Recursive algorithms are very easy to write. Sir, I think you have seen in our beginning demo sessions also, we have covered some problems by using recursion, right? There you can see a small piece of code, how beautifully we can able to implement. Okay, not that much hard to write the code. Second one, sir, it gives leads to solve, easy to solve, okay, easy to solve natural big problems. Like we have so many problems are there. Example, if you want, I think you have heard about towers of Hanai. Sir, anyone heard about this towers of Hanai problem? Can you please confirm? Anyone heard about this towers of Hanai problem? Can you please confirm? No, na, ayyo. Okay, no problem. We will discuss that also with the help of coding. Don't worry at all. Okay, we will discuss that. Yeah, it is a something like a game. Yes. Sir, you can able to see. I will show you the diagrams. Yes. Okay, sir, something like in your childhood, maybe you have seen. Okay, this is nothing but some solution I have here. Okay. Yes, we have solution here. Yes, you can able to see. Yes. So like this, we have three towers are there, like A, B, C. Sir, we have to move the disks. These are called as a disks from source to destination. Here source is A, destination is C. There are some rules that we have to follow. Sir, some rules are there. Maybe you have remembered the first rule is nothing but you have to move at a time only one disk. Okay, you have to move at a time only one disk. Second rule is what? Sir, you can't keep first lower disk on that higher disk. With respect to size, I am talking. You can't keep lower disk. So after that higher disk, it is not possible. Always a higher disk should be at the bottom. So on the top of that, you have to take lower disk. So like this, you have to move one step. So meanwhile, you can use one auxiliary tower, which is nothing but B. Sir, now first, have you observed here? Red color disk is to this last. This is the first step. Then white color disk is to the B. This is the second step. Sir, then this red color is to on the top of white. Sir, is it following our rule or not? Yes. Next, this green color we are moving to the end like this. Next, this red color we are moving to the A like this. Now, sir, this white color we are moving to here. Sir, next we are moving this red color on the top. Sir, now you can able to see. Sir, to get the values from this to this, how many steps we have made? This is a small problem. Since we have three disks are there, maybe 7 or 8 iterations is required. Suppose if you have four disks, then a problem is big. Of course, we will see this with the help of live examples. Don't worry at all. So this kind of problems. So once if the number of disks are increasing, sir, it is very hard to implement. Suppose if you have only one disk, easy, right? We can move. If you have two disks, maybe somewhat difficult, but we can plan. So if you have three disks, sir, if you want to move three disks, what is the formula that we are using for two disks plus what is the formula that you are using for one disk is the solution. Suppose if you have four disks, one disk solution is equal to three disk solution plus this solution. Like these recursive algorithms we can implement for this. So this is nothing but one of the consideration just I am taking. So like this, we have n number of applications are there. Don't worry. We are going to discuss about this towers of Hanai also. No worries at all. Next, Sir, it is going to reduce unnecessary. Okay, it is going to reduce so unnecessary function calls. Sir, first of all, no need to remember the function calls. Only one function will be there, right? Suppose if you are taking factorial of a 5, so you need to call only fact function. So no other function is required, right? No other function is required. Like that we have. So we can reduce unnecessary function calls by using this. Next. Sir, what is the next one? It is going to reduce length of the code. Okay, so it is going to reduce length of the code. Sir, I can able to reduce the length of the code, no problem at all. I can able to reduce length of the code. So someone told in the very beginning, when I am talking about advantages, sir, code reusability, length of the code is going to decrease, like this someone told. Yes, it is the biggest advantage. Sir, next, what is the next advantage is nothing but, sir, it is very useful. Sir, it is very useful while solving, okay, while solving data structure, while solving data structure related problems. Sir, while solving data structure related problems, it is very useful, sir. Okay, which one? Recursion is going to give best results when you are solving this. Okay, yeah, trees, AVL, correct. Chaitanya, trees, AVL, trees, yes. Okay, anyway, we are going to discuss that in our course with the beautiful diagrams. Don't worry at all. In future, there is one proverb is there, right? In front there is crocodiles festival, right? In the same way, in front we have Diwali, Sankranti, Christmas, New Year. Okay, so we have so many festivals are there. Try to enjoy. Okay, yeah, I am talking with respect to data structures. Next, sir, even we can evaluate. Okay, we can evaluate some expressions. Okay, something like infix expressions, prefix expressions, and postfix expressions. Do you remember? These are the applications of stacks. So we can evaluate the postfix expression. Like this, we have some scenarios. These things we are going to cover in our stack data structure. We will take some algorithm, and how beautifully we can able to implement also we will discuss. Sir, if you talk like this, we have n number of application areas are there, that is advantages when compared with normal functions. So I think this concept is very clear for you people. So do you have any doubts in this recursion advantages? Can you please confirm? Yes, yes, I request everyone to please respond. Right, sir. Something is there like, sir, if you want to get advantages, at the same time there will be disadvantages in every area, right? Yes, now I'm getting something, definitely you need to lose something, so otherwise you won't get these things, right? Yes, correct, Kasredi, correct. Suppose if I want to get fruits tomorrow, sir, today I have to struggle like anything. Okay, we know that feature. So on the same point, recursion is also having some disadvantages. Okay, so in some areas it is good, in some areas it is not good. Sir, can you please tell me what are the disadvantages of recursion? Sir, what is the disadvantage of recursion? Yeah, correct, Chaitanya. So while recursion, memory gets occupied. Yes, good, that is my first point also. Sir, this recursion uses extra stack space, right? Every time the method calls or the values or operator related controls, everything, where it is going to be stored in our stack or not? Yes, so definitely our recursion is going to use some extra stack space. It is going to use some extra stack space, and it require redundant redundant computations. Like if any computation is already calculated, sir, again and again it will calculate or not? Yes, best example for this, sir, do you know, consider I am calculating Fibonacci sequence for the number called 5. Okay, Fibonacci number sequence for this number called 5. Sir, first what it is going to do? It will calculate Fibonacci sequence for, sir, I think, yeah, 4, right? So fourth digit. So under simultaneously it will calculate for, sir, 5 minus 1, that is 3, right? Have you remembered recursion? 1 minute, I will take a tree diagram so that you can get clarity. So consider I have to find out the Fibonacci sequence. Okay, I want to calculate, sir, Fibonacci sequence. Maybe I have given the input as a 5. Sir, how it is going to calculate? Sum of previous 2 digits, right? It will calculate a Fibonacci sequence for 5. So previous 2 numbers means not 5. Sir, you will get for 4 and you will get for 3. Now observe carefully. For 3 means again it will calculate for 2 and it will calculate for 1. Sir, 1 means it will calculate for f of 1 and it will calculate for f of 0. Okay. Sir, here also we will get f of 3 and f of 2. Sir, for f of 2 again you will get f of 1 and you will get f of 0. Sir, for this f of 3, again you are going to get f of 2, so f of 1. So for this f of 2, again f of 1, f of 0. For this f of 1, again f of 0. Sir, have you observed here how many times we calculated f of 1? 1, sir, 2, 3, sir, 4, 5. Sir, how many times? 5 times. Sir, is these 5 entries will be there in the stack or not? Yes. But all these 5 entries are having only one value, right? Because f of 1 is fixed or f of 0 is fixed. These duplicate entries will be there. So redundant computations is required again and again. So announce wastage of time, right? So this is nothing but what we have. That is a third difference. Then, sir, sometimes tracing will be difficult. Of course, I am talking this point with respect to user point of view. Sir, if I want to trace, sir, maybe this application also you can able to see somewhat difficult, right? Suppose if you take a Fibonacci up to 10, sir, what will happen? A big diagram you are going to get. So sometimes you may get very difficult to trace. So once if the input size is increasing, that is also very difficult. But this is not with respect to program, with respect to user point of view. So means programmer point of view. But programmer is the ultimate hero or not? Yes. While writing the program, you need to practice the algorithm and you have to check how it is going to work. So for all these things, compulsory tracing must be required. So that tracing will be difficult here. Okay, this is nothing but what we have. And sir, sometimes it is taking slower. Okay, sometimes it is nothing but slower. Okay, sir, with respect to time, sometimes if any more calls are there, it will take some time, sir. That is nothing but sir, one situation. And the last disadvantage, of course, this we have seen, sir. Sometimes it is going to run. Okay, runs out of memory also, sir. We have seen several times we are going to get a stack overflow error or not? Yes. Sir, is the out of memory or not? Yes. Because my system has given some kind of space for the stack to hold these entries. Sir, if that space got increased, what will happen? Sir, out of error, out of memory error we are going to get. This is nothing but one more disadvantage what we have. So these are nothing but advantages and disadvantages in our recursion. Can you please confirm, sir, is these disadvantages are clear for you people? Yes, yes, it is completely developer's choice, Neeraj. Yes, we can find the size of the stack, Kiran Kumar. We can find the size of the stack, but it will be provided in the documentation of corresponding language. Slower in execution. Okay, it is going to execute a little bit slow. Kasireddy, I have written slower in execution. Please explain redundant computation. See here, you got this diagram, right, Kiran Kumar? Vishal, when we say recursion uses extra space, then it is directly impacting space complexity, right? Yes, of course. Definitely. But one more thing, Vishal, you need to remember this. I told already, someone accepted also. So if you want to get something, we are going to lose something, right? Suppose if I am getting more time to execute, okay, my algorithm is taking much time to execute, but if I use recursion, almost half of the time it is going to reduce. Then we will choose or not. Definitely we will choose recursion because, sir, even if the space increase, no problem, but time is our important factor, right? Because how much speedily you are going to provide application for the end user is matters nowadays. So you can able to see in my childhood, I have seen 512 MB floppy disk drives and 1 GB pen drives, 512 MB pen drives, like that I have seen. But now today, sir, every person is using 1 TB. Okay, sir, 512 500 GB, like this the memory unit is also coming along with that, right? So we can able to consider that point also. Clear? Yes, yes, definitely. If you want to get time complexity, maybe space complexity somewhat down. If you want to get a space complexity, maybe time complexity. Neeraj, Ajit Neeraj is telling every coin has two sides. Yes, right. Now, sir, someone is asking, can you please explain that redundant time? Okay. Yeah, yeah, we will see. Which one, Kiran, you are asking? Time and space complexity or redundant? Yeah, yeah. So just one small example, please remember. Maybe if time permits, I will trace that in future. Suppose I want to calculate, sir, Fibonacci for 3. So Fibonacci means what? Sum of previous two numbers. Sir, what is the formula for that? So I'm writing the formula. F of n will become, f of n will become 0. Sir, when if n is equal to 1. Okay. F of n is equal to 0 when n is equal to 1 or 0, something like that we are going to write. Forget about that. We will discuss anyway Fibonacci sequence we will get maybe tomorrow. So otherwise f of n is equal to f of n minus 1 plus f of n minus 2, sum of previous two numbers. So in that point of view, f of 3 can be written as f of 2 and f of 1, right? N minus 1, n minus 2. Again, f of 2 can be written as 2 minus 1, 1, and this one 2 minus 2, 0. So this f of 1 can be written as f of 0, right? Like this we are going to get. Whenever you are getting 0, this is the base condition. Have you remembered how many times we are using f of 0? 2 times. Is it redundant calculation or not? Redundant means repetition. Yes, this entry will be redundant. Okay, repetition. So that is the point which I am trying to explain. Clear, Kiran? Right. Sir, now, yes, Manoj, your point is correct. Manoj is telling one point. This is nothing but the point. Sir, what I remember is Java has garbage collectors which clears memory after execution. So, why we need to worry about space complexity at all? If you remember, one day I clearly explained about this point. What is that? So, you need not to consider space complexity for your algorithms because the days are going very effectively. So, every programming language by default, they are supporting for us with respect to memory. They will create an object. If you are not using that object in anywhere in your code, it will destroy that object automatically. If you are using that object, it will check how long it is using. So once if that usage completed, automatically it is detecting and it is deleting. Such a type of powerful missions are there in our languages. So that will take care of our code. That's why no need to worry about space. Maybe at the time of execution, if it is taking more space, once if the program execution completed, that memory space will be released, right? So that there is no worry at all. But you need to consider as a theoretical part. Clear, Manoj? Right. Yes, we can save redundant operations and can we reduce time? Yes, of course. That depends on our application. When we have input in a pattern, then we can use recursion. But if it is not in a pattern, then see, directly we can't give that guarantee. For any problem, you can provide a solution in recursion, provided it should be following these styles. If it is available in this style, you can able to do. Sir, for every problem, for every recursion problem, I'm going to take these 3 steps. Okay, I will take the multiple codes. Don't worry. Minimum 10 to 15 programs I'm going to cover on recursion. Then you will get clarity. Clear? Right. Sir, now the next point. Next point, what we have? Yeah, please. If we can solve problem 1 for loop. Yeah, looping state. That is today's. I mean, this topic I'm going to explain. Clear? Sir, what is the difference? What is the difference between? What is the difference between, sir, iteration? Okay, otherwise, first let me take recursion because recursion is our hero. Recursion and iteration. What is the difference between recursion and iteration? Yes, of course, definitely difference will be there. Sir, first I am going to take recursion. Okay, on the other hand, I am going to take iteration. Let us see, sir, what will happen. What is this recursion? First point, sir, recursion is nothing but, sir, base condition. Base condition is required. Base condition is required. On the other hand, in recursion also, okay, in recursion also, sir, it will terminate. Otherwise, here, sir, it terminates, sir, when base condition is not satisfied or base condition is false. Sorry, base condition is true. So when it is going to terminate, sir, when base condition is true, it will terminate. And when this iteration is going to terminate, sir, it terminates, sir, when our test condition is false. Whenever your condition become false, it is going to terminate. But when recursion will terminate, if the base condition is true, it is going to terminate. This is the first point. Okay. Chaitanya, please wait. Sir, while class is going on, please don't keep any messages, sir. Once if I came to discussion, then you can send, please. Then second one, recursion uses functions concept. Okay, compulsory you must be very strong in functions. Then only you can able to prepare recursive algorithms. What about iterations? Sir, for iteration, you must have a strong idea in looping statements, right? Sir, how many looping statements are there? Looping statement or looping concepts? Sir, we have while loop is there, for loop is there, do while is there, for each loop is there. Like this, we have different types of looping statements are there. So you must be very strong in that. Then, sir, here extra space, okay, extra space is required. Extra space is required. But make sure here extra space is not required. Extra space is not required because here in loop maximum, if you want to calculate a sum of n natural numbers, sir, if you give n value as a 5, sir, the amount of space required when you are implementing by using looping statement maybe some I variable, n variable, and then that sum variable, right? Only 3 units I can able to say. But when you are using recursion, what will happen? Sir, first time n is equal to 5, 1 unit. Next time the complete method call is going to be changed or not. At the time it is going to use one more memory cell. So 1 unit for 4. Next time 1 unit for 3. Next time 1 unit for 2. Next time 1 unit for 1. Next time 1 unit for 0. Sir, total 6 memory locations are required. I can say 6 units when you are using recursion. But when you are using iteration, that much is not required. Okay. This is nothing but one more difference what we can able to explain. Then, sir, in recursion, sir, we can write a smaller code, right? And here, sir, we can write a bigger code. So that we can able to get. Okay. So I told, right, if you want to get these kind of benefits, you have to compromise with space. This is nothing but we have so much of differences are there. Sir, I can say these are the main differences between, okay, these are the main differences between recursion and iteration. Sir, clear up to this? Please confirm everyone. Any doubts? Yes. Sir, on the recursion topic, sir, what topics we covered? What subtopics we covered? Sir, first we have seen introduction. Introduction to functions. Then, sir, why recursion? Why recursion concept is required? That part also we have seen. And recursion means what? So next and after that, we have seen finite and sir, infinite. Infinite recursion means what? Sir, before that, so we have seen base condition also, right? So what is mean by base condition? So when we have to develop this base condition also, we have seen. So next and after that, what is the next topic we covered on this? Sir, yeah, yes, base condition. Next and after that, yes, mathematical interpretation of recursion. How you can able to convert your mathematical expressions into recursion. So after that, we have seen today's session. That is nothing but properties. So what properties we have for recursion? If I want to implement a recursive algorithm, what properties we have and what are the advantages and disadvantages of recursion? Okay, sir, what are the advantages and disadvantages of recursion? Sir, after this, we have seen what is the difference between, sir, iteration and recursion. So I think almost all the theory concepts we completed. From tomorrow, we are going to talk about the programs. Okay, almost in my hand. So 10 to 15 programs are there. Some programs are repeated, some programs are new programs. So you need to concentrate fully on recursion. Sir, again, I am repeating, if you people are not getting any program, you can ask me. I will try to repeat one more time. Okay. But don't ask third time or fourth time, please. Okay. So I request everyone to please put concentration. Some programs are simple programs. You can able to understand. But some programs are difficult to understand. There step by step I will explain by taking our Java code. Okay. Sir, clear up to this? Any doubts? Right. Right. So that's all about today's session. Sir, WhatsApp group is not yet created. Please wait. Okay. Some people already have my number. They have sent the information also. So some people are not having my number. Don't worry. I will give. Definitely, I will create a WhatsApp group. Please wait. Okay. Right. Sir, the people who joined at 5 o'clock, don't worry. So I'm going to give the running notes access by today night. Okay. Sir, when we'll do the programs which will show internal stack diagram, how to push us new calls and pop calls. Yeah, maybe in this recursion, if time permits, I will provide one example for this. So otherwise, we will see in the stack. Okay. Applications of stacks are there, right? There I may discuss, but maximum I will discuss in the stack. If not, it will be covered under recursion. Okay. Right. So thank you guys. Sir, this data structure, till now there is no book. Okay, you have to practice. Yeah. So the people who joined from 5 o'clock batch, don't worry, today you are going to receive the running notes, right? So thank you guys, see you tomorrow. Yeah, videos I don't have any control, sir. Admin people are going to upload the videos, I will inform them. Okay, max you can wait for a few hours and then you will get it, right? Thank you, good night.